Cause it's rain, rain, rain down on me. Each drop is pain.
My name is Vicky, and today I'll be talking about part 1 of our Lab E3, which is the 7-segment display. This is our schematic diagram. First of all, we are setting the input, which we are using port B0 to port 3, and for the output we are using port D0 to port D6. For this whole circuit, we are constructing it as an active low circuit. Okay, so moving on to our coding. The first function we are using is the void initialize digit function. In this function, we are just enabling the clock for port B and also for port D. And here, we are setting the port direction. So the next function will be the set digit function. In this function, we are just lighting up the LED by using the binary coding. And then we put these two functions into the main function, into the for loop, so that it will repeat itself. And then that is all. So now moving on to our real circuit. So now the LED lights up at 0. And then... sorry. Okay. So 1, 2, 3, and back to 4, 5, and then 6, 7, then 8, then finally 9. Okay, that is all. Thank you. Hello, my name is Vicky. I'll be talking about part 2 of our Lab E3. So basically it's about the analog to digital converter, where we use our FRDM board, and since the ADC is built into the FRDM board in this MK20, so basically in this part of the lab we are required to use channel 19 as the output, and since channel 19 is directly connected to the light sensor, so it will be much easier that way. So moving on to our coding C+ here. So as you can see, SIM SCGC6, this coding is required to enable the ADC. So as you can see the startup here. So now moving on to the initialize ADC. As we can see here, this for the initializing for setting normal power configuration, clock divide ratio to 1. And moving on, we'll have a software trigger here and not. So to enable the calibration, we enable this single conversion, and for this part 32 sampled average with the value of 3. So as you can see here, we use a while loop so that we can check if the conversion is completed or not for calibration start, and to check if it fails or not through simple printf process. So moving on to our do ADC conversion, this is where conversion process occurs. So as we can see, we have set our ADC channel 19, which is directly connected to the light sensor, as I stated earlier. So what we have here is light. Light is actually the raw data that is being initialized up here and being set inside the ADC or lower dash RA. So this is the simple calculation required to calculate the voltage value in the first integer to both the decimal value V2 and V3, and this output will be printf onto our serial terminal, which we use kitty, and this is just the basic delay function. So moving on to our kitty to check for our output, we will first debug. Okay, it's successful. So as we can see, starting from here, so the calibration is successful, and as we can see, the value is high now. So what is expected is that when I from the view of the board, when I cover the light sensor, so you see the value increase. So basically, low light intensity will increase the value of the voltage output. So now we will use the flashlight of our smartphone. So as we can see, if I put the light closer, so increase the light intensity, we'll have a lower raw data and also a lower voltage output. So when I pull the smartphone away further, you can see an increase in voltage value. So therefore, I can state that our expected result is same as our actual result. So therefore, I would like to end my part. Thank you.
Hello, I'm Melvin. I will be demonstrating part 3 of the lab 3. For this part, actually, it's the combination of part 1 and part 2. The code are basically the same, only 2 small changes. The first one is that the input in the part 1 is being removed. As for part 3, is the input actually the light sensor. And for the do ADC conversions, we add in a several range of number based on the raw data to display in the 7-segment display, and that's the only 2 change in the code. And moving on to the kitty, let me debug it first. And yeah, it displays the same thing as the one in part 2. And now moving on to the circuit. As I move closer to the light sensor, the number will start from 0 and slowly change to a higher value from 1 to 2, 3, 4, 5, 6, 7, 8, and finally 9. As I slowly move away from the light sense, so it will slowly decrease and reach 0 again. And that's all for my part. Thank you.